This film supplements the instructions for use and serves to aid understanding. This film is not a substitute for reading and understanding the instructions for use. It is also not a replacement for mandatory instructions or training courses. A recent study published in The Lancet Respiratory Medicine impressively concluded that neonatal and pediatric patients run a significantly higher risk of anesthesia-related complications. During anesthesia, the accuracy of applied tidal volumes is very important when ventilating pediatric patients, especially small children, while any small deviation from the set tidal volume can be a big deviation for these patient groups. In order to provide the best care for pediatric patients, Dräger ventilation technologies and functionalities support the recommended protective ventilation procedures and approaches in the best possible way. Flow sensor measurements are used to calculate the tidal volume delivered to and being expired by the patient. Thus, a high precision of flow measurement is crucial for exact tidal volume delivery. Depending on the technology used, condensation can impair precise measurement of flow sensors. Ventilators that are depending on this measurement will not be able to perform accurate tidal volume delivery. Dräger devices use flow sensors with heated wire anemometry technology, which has been proven as very reliable and precise even with low flow rates and thus low tidal volumes. Due to this technology, the Dräger flow sensors are very resistant to humidity and condensation. Even in the unlikely case of a flow sensor failure, via the stepper motor moving the piston, the ventilator always knows the piston's position to calculate the tidal volume to be delivered. Therefore, the functionality of the piston ventilator is independent of flow measurement. The piston ventilator in Atlan family is designed to deliver precise tidal volumes. The volume control autoflow mode of Dräger ventilators combines the advantages of volume-controlled and pressure-controlled ventilation. Autoflow ensures the delivery of the set tidal volume at the lowest possible pressure in a pressure-controlled pattern. Especially to protect the pediatric patient's lungs, precise application of ventilation pressures is of vital importance, because excessive pressures may harm the lung by overdistension, whereas loss of PEEP can induce atelectasis. Also, the eVent Plus piston ventilator in Atlan family devices deliver fast and precisely the set ventilation pressures. This is specifically important in ventilating pediatric patients who have high respiratory rates, and thus pressure targets have to be achieved very quickly. Children's lungs are very vulnerable, and therefore when ventilating a child in manual spontaneous mode, the precision of the APL valve is highly important. The APL valve should ideally produce a linear pressure profile so that the pressure in the system should precisely correspond to the set value. Nevertheless, a recent study found that one of the two APL valves compared in this study delivers pressure patterns that can deviate from the intended pressure by the user, thus not allowing for safe bag-assisted ventilation. Whereas the Dräger APL valve delivers a linear near pressure profile, and the delivered pressure never exceeded the set APL valve value. All Atlan family devices use the same APL valve, which delivers a linear pressure pattern and thus reliably prevents excessive pressures in manual ventilation. Compliance refers to the fact that parts of the system volume of an anesthesia device, including the breathing hoses, can expand upon pressure. This causes them to take up volume, which should actually be delivered to the patient. Therefore, compliance has to be determined and compensated accordingly for accurate tidal volume delivery. Dräger anesthesia ventilators are able to compensate for the compliance of the breathing system and hoses, which is determined during the self-test. A According to the compliance, the needed additional volume is calculated and compensated to deliver the exact tidal volume for each breath. Depending on the technology employed, fresh gas flow can also significantly influence the tidal volume delivery and compromise tidal volume accuracy. In some anesthesia machines, fresh gas compensation is used to eliminate this influence. With this technology, the inspiratory flow sensor is monitoring the delivered tidal volume and adjusting the ventilator accordingly to compensate for the fresh gas flow changes. Additionally, if rapid changes in fresh gas settings are made, the system latency causes a delayed compensation of tidal volume. This may result in tidal volume and inspiratory pressure peaks. Moreover, this function depends on the proper functionality and precise measurement of the flow sensors. In case of flow sensor failure or impaired measurement due to condensation, the fresh gas compensation will fail. Also, every time when oxygen flush is used, this will influence the delivered tidal volume. The Dräger-specific solution, called fresh gas decoupling, is a much more direct and effective solution for this issue that ensures that the fresh gas can go to the reservoir bag and scavenging system, both during the in- and expiratory phases. In the Atlan family anesthesia devices, the fresh gas decoupling valve ensures that fresh gas flows during inspiration into the reservoir bag and the piston volume is delivered to the patient, so that even when the O2 flush is used, the generated tidal volume and airway pressure do not change. Leakages can have significant influence on ventilation. Although system leakage can be identified during the leakage test and compensated by correspondingly increasing tidal volume, this does not prevent the PEEP from falling or even diminishing between expiration and inspiration. The Event Plus piston ventilator in Atlan family devices actively holds PEEP levels by moving the piston upwards during expiration and thus compensating for lost volume due to leakages. In ventilation of small children, it is vital that the system detects the smallest effort of spontaneously breathing patient to provide support when it is needed. Also, the breathing system resistance should be as low as possible to reduce the work of breathing. Dräger anesthesia devices provide highly sensitive flow triggers, so that even weakest spontaneous breathing attempts are reliably detected. The Event Plus piston ventilator in Atlan family devices regulate its movement during expiration to synchronize with the expiration flow and so actively support the patient's expiration. Smaller children are ventilated with higher frequencies, which can result in very short inspiratory times. Especially the minimum expiration times which are needed to avoid air trapping can lead to very short inspiratory times. Therefore, to deliver the set tidal volume during this short inspiration time, anesthesia ventilators should be able to provide high inspiratory flows, enabling high respiratory rates. Preparing the anesthesia workplace is of utmost importance. Once the small patient is induced, the time for oxygen desaturation can be as short as 90 seconds. Therefore, a swift change by the device to appropriate mechanical ventilation is essential. Atlan family anesthesia machines facilitate this by offering customized pre-setting for all patient categories, including pediatric patients and neonates. After selecting patient category, relevant settings and alarms will adapt automatically, with only few manual adaptations needed when necessary. As children desaturate very quickly, and the younger the child, the quicker oxygen saturation deteriorates. In children, a reliable measurement of gases, especially oxygen, is crucial. For oxygen measurement, different technologies are available on the market. Depending on the technology used, some of the anesthesia devices require a reference gas for precise measurement. This technology implies that the sample gas extracted from the breathing system is mixed with a reference gas, which has a different composition than the gas mix in the breathing system. Therefore, returning this sample gas to the breathing system can significantly alter the gas composition within the breathing system. Especially in low and minimal flow anesthesia, it may lower the portion of oxygen and anesthetic agent and accumulate nitrogen in the entire breathing system. Due to this issue, some devices utilizing this sensor technology may not return sample gas back into the breathing system. However, not returning the sample gas, which is usually approximately 200 milliliters per minute, means a systematic leak of significant magnitude. That's why these devices are not able to operate at flow rates of less than 500 milliliters per minute. Dräger deploys paramagnetic as well as electrochemical O2 sensor technologies, which do not use reference gas, so the sample gas, which is always returned back to the breathing system, does not change the gas composition, and there is no systematic leak which needs to be compensated. Therefore, with Dräger anesthesia devices, it is possible to operate efficiently at flow rates of less than 500 milliliters per minute. During general anesthesia of pediatric patients, a quick change in gas compensation can be crucial in order to counteract oxygen desaturation and improve oxygenation rapidly. The anesthesia device has to be designed accordingly to deliver the gas composition changes quickly to the patient. The breathing system volume and the fresh gas flow rate have significant influence on the reaction time. The higher the breathing system volume and the lower the fresh gas flow means the longer the time constant. The Dräger Atlan family anesthesia machines are designed for low breathing system volumes with short time constants. The breathing system of the anesthesia device has to be as tight as possible to minimize system leakages, which can have an impact on delivered tidal volumes. The breathing systems of all Atlan family anesthesia machines consist of only a few parts to reduce the number of connections for potential leakages. And unlike other anesthesia systems, the breathing bag in Atlan family anesthesia machines is an integral part of the breathing system that acts as a fresh gas reservoir and indicator for adequate fresh gas flows. An empty breathing bag indicates a fresh gas deficit, and that the fresh gas flow needs to be increased. Not all products, features, or services mentioned in this video are available for sale in all countries. Contact your local Dräger representative for more information. Mentioned trademarks are only registered in certain countries and not necessarily in the country in which this material is released. Go to dräger.com/trademarks to find the current status.